Hey mathematicians, here is our first attempt for Math 3 at an e-learning video. We're going to talk about Learning Target 8D, which is I can solve logarithmic equations. That's Book 3, Section 5.5. Before we begin right into the log equations, I want to do a little bit of review. So I'm going to talk about solving exponential equations with common bases. So let's go ahead and review that. So first, let's say we have something like this, 3 to the 2x minus 4 equals 3. Let's say to the 5 minus x. Oop. That was my Mr. Kitty Jr. Sorry about that. Trying to study this up, sorry. So once you have the same base, and in this case we're given the same base, all you have to do is take the equation up here and set it equal to each other. So we would take 2x minus 4 equals 5 minus x. In this case, I would add x to both sides. So I'm going to get 3x minus 4 equals 5. And then I'll go ahead and add 4 to both sides. So 3x equals 9, which would mean x is 3. Another example that we talked about with getting common bases, perhaps we have something like this. Let's say you have 5 to the x minus 1 equals 25 to the 2x plus 4. So in this case, we can't set these two equal to each other because we don't have a common base. So we have to get a common base using the 5. So I'm going to rewrite this side, 5 to the x minus 1 equals, and I'm going to use that 5 as my base, and I know that 5 squared is the same as 25. So I'm rewriting 25 here as 5 squared, and then 2x plus 4. Now, remember that when we have power to a power, we have to multiply our exponents. So again, this is going to stay the same as 5 to the x minus 1. And here, the 5 stays here, and I'm going to multiply 2 times 2x, which is 4x, and 2 times 4, which is 8. So now I'm back to where I was, like in the previous problem, where I can just take the exponents and set them equal to each other. So you have x minus 1 equals 4x plus 8. I like to keep my variable positive, so I'm going to subtract x here and go negative 1 equals 3x plus 8. Then I'll subtract the 8 from both sides, get negative 9 equals 3x. And divide by 3, and this time you get x equals negative 3. So that's a little bit of review as to what we had done before. I also want to review change of base. So let's take a look at a problem like this. Let's say we have something like 4 to the x equals 12. So when I look at this, I don't know a number that can go in here that makes sense because 4 to the first power is 4 and 4 squared is 16. So I'm not going to get an exact answer here. So I'm going to rewrite this using logs. Remember, the base of the exponent becomes the base of the log. And then these two numbers will switch. So this becomes log base 4 of 12 equals x. Now I can use this, or I can rewrite this using change of base. Remember, we remember base to bottom. So I'm going to use a fraction saying x is equal to log 4, that goes on the bottom, base goes to the bottom, and then in the numerator it's log 12. So to put that in my calculator, I use the log button, which is right here next to the 7. So I'm going to say log 12. Oops, need to actually turn it on. So again, let's log 12. Remember, you have to close the parenthesis here. That has to get closed or it's going to come out wrong. So we've got log 12 in the numerator divided by, and then log 4. So that's called change of base, and you're going to get 1.8 there. So x equals 1.8. And if we were to round to the nearest thousandth, just so that you have that, that's 3 places past the decimal, it would be 1.792. So 1.792, because on Big Ideas, they do want you to go to 3 places past the decimal. All right, let's try some new type of stuff here. So we've got some examples here. So that was all review. But let's look at another problem. So this one's going to be using our number e, which is something that we use in different equations. It's kind of like pi. It's an irrational number. And to take the inverse of that, we use something called the natural log. So let's say we have something like this. 3e to the 2x plus 1 equals, let's say, 13. So just like with any of our other things, like when we're dealing with square roots or exponents, we want to isolate this e here. So we want to get this by itself before we can do anything else. So we're going to follow what we would normally do to solve equations. So I'm going to subtract 1 from both sides first. So that gets rid of that, and we get 3e to the 2x equals 12. And again, I can't do anything here yet unless I get rid of this 3, this number in front of here. So I'm going to divide by 3. So now I have e to the 2x equals 4. Okay, so like I said, what we call the natural log is the inverse of our e here. So in order to get rid of e, I have to take the natural log of both sides, because if I do it to one side, I have to do it to the other. To write the natural log, it's written as ln. So ln of e to the 2x, but again, I put that natural log in front. That's going to be the natural log of 4 as well over here, because I have to do what I do to one side, I have to do the other. What that does is it gets rid of e, so I'm left with 2x equals, and then the natural log of 4. So then finally, to get this, and you can use parentheses or not parentheses, it doesn't matter. Both notations are fine. So now to get x by itself, I'm going to divide by 2 and divide by 2. This would be called an exact answer. So if a problem is looking for an exact answer, you would just leave it as x equals the natural log of 4 divided by 2. If you want a decimal answer, the natural log is right here under the log. So log is here, natural log is here. And if you notice, the second is e to the x. So I think we talked about this before a little bit, but if you look at your calculator, for example, division and multiplication, they're right next to each other, and they are inverse functions of each other. They undo each other. Addition and subtraction, they undo each other. The inverse sign is the inverse function of sine. They undo each other. Or the square root is the inverse function of x squared and vice versa. So it's the same thing here. The inverse function of natural log is e, and e is the inverse function of the natural log. So if I want to put that in my calculator, I would hit that ln button right here. So I'm going to get the natural log of 4. Again, super important to close your parenthesis here. If you don't close your parenthesis here, it's going to be wrong. Then divided by 2. So again, I'm going to go 3 places past the decimal, so 0.693. So my estimated answer would be x equals 0.693. All right, let's go ahead and try another problem. So let's say I have something like log base 3 of 2x minus 4 equals, let's say 5. So in this case, I've been given a logarithmic equation and I want to solve for x. So to undo the log, we're going to change it into exponential form. So we're going to take the base of the log and make that the base of the exponent, and then these two things are going to switch. So 3 to the 5 is equal to 2x minus 4. And now it becomes a pretty simple equation, because if I do 3 to the 5 power, 3 to the 5th power, that's 243. It's 243. So 243 equals 2x minus 4. And then we're just going to go ahead and solve it like we normally do. Add 4 to both sides. So you get 247 equals 2x. And then when we divide by 2, x is equal to 123.5. Okay, so what I'd like you to do is make sure you get these notes in your notebook, and then you're going to work on the big ideas assignment that goes with that. That's going to be section 5.5, and hopefully everything is going well for you. Thanks. Bye.